Welcome to this tutorial in which I like to show you the measurement flow control, short MFC. With the measurement flow control you can automate your workflow and it is very helpful in all situations where you have to repeat the same process several times. Let's go into the measurement flow control menu. You can find it in the ribbon bar and click on the edit button. In this dialog window you can add your commands by drag and drop the command from the command list on the left side. You can also add commands by double clicking it and they will get inserted in your measurement flow. For changing the order, just drag and drop the commands on the place you want to have it. For deleting it, just click on delete on your keyboard. On the bottom you can change how your flow is executed. Single means that if you start a measurement flow control, it is run for one time. If you click on repeat, it will repeat until you stop it manually, or you insert the stop command. With the event mode, you have the possibility to run the flow control event trivially, for example, by defining a time interval or a sample interval. In the remote mode you can download the MFC to your TranAX device. If you activate remote, you see that only some of the commands left are highlighted. Only these commands can be used on the remote measurement flow control. Let's get started with a simple example. We want to start the measurement, wait until it is done, and showing a message to the operator. For that we click on Start Recording. Next we have to say that we want to wait until the measurement is done. It could be that, for example, if you have a long measurement, it could take a while until this measurement is done. And so we insert here wait on EOR means wait on end of recording. And then we add a message to the operator. For this we use the pause command and add a message here. For example, measurement done. Now we have to start the sequence by clicking on execute in the ribbon bar. And you see that the measurement has been done and the message is shown here to the operator. To continue, click on continue or abort for stopping the flow control. We change now the mode to repeat and we can see that the sequence is repeated forever. You have to click on abort on the message or stop the measurement flow control in the ribbon bar by pressing on the stop button. Now we make an example with the event. We use the time interval and specify a time interval of 2 seconds. We start the execution. In the yellow bar on the top of the sequence you see the timer running. For easy debugging, the command actually executed is highlighted. So if you start the measurement flow control, you see the yellow background color showing which command is actually active. For fast processing, it is recommended that you disable this highlighting. You can make this in the ribbon bar. If you start the measurement again, you will see that there is no highlighting anymore and the execution time will be less. It is also possible to have a loop inside of one task instead of using the repeat function in the mode. So we switch back to single mode and we add the repeat function as a command in the command list. we add repeat, and you see there is also a corresponding next. So everything between these two is repeated. And you can change the number of repetition here in the menu. So let's have a look how it looks like. We start the measurement flow control, and you see the repeating counter is decreasing until it reaches 0, and then it jumps out of this loop. So for storing to a file, that's the next key function. It's the function save. And here I can specify a trace name, and I can specify which channel should be stored in this file. So in this case, I only want to have channel 1. You can also specify some data reduction here. Keep that. And I say add channel for having this channel here in this list. And if you want to generate each time a new file with index, you have to type here a hashtag, and this will generate a trace 1, trace 2, trace 3, and so on. I can close that. Then I start the measurement. And so if I have a look at my single source browser in my experiment folder, it has generated this trace 1, 2, 3, 4 until 10. For example, you can also add each time here pause function to tell your operator change something, change device under test, for example. And so this will indicate you that you have to do something, then continue, it makes the next measurement. Next example is to show you how to use the formula editor together with the measurement flow control. For that I remove this save command here, and I add the calculate button here. Calculate, and I say also calculate after each measurement my formula. If your formula takes long and it's important that the calculation has been done, so activate wait for calculation here. By default you are calculating the main formula. You see I've prepared already a formula. This is normally the main formula, so if you don't give here a explicit name for a formula, it will be the main here. So if you have several formula, you have to change that here. So, and in my formula I actually get the measurement data from the hardware, and I calculate a low pass filter on that signal. So I've prepared also here a waveform with my hardware curve, and with I've prepared already one filter curve. So if I start here the measurement, it starts recording, and you have seen it has adapted here the calculated curve also. So this is my filter signal from that. If I continue, see this will calculate your formula each time. So what we can do also, for example, we could calculate a mean value, mean equal mean as filtered, and write that to file, write line my calculations text file tabulator, and this is my M. If I stop that now and I go to my single source browser, I have here my calculation. If I double click or load file, and you see I have here my calculated mean values in my text file. So that's how you can use the measurement flow control to calculate a sequence of data Next short example is to show you how to use several tasks in parallel. So you can add several tasks here, so make a second task, and by default they are running in parallel. So if you want to synchronize them, you can use these events here. In my first task I say, okay, all 5 seconds I release my event with the name my event. And on my second task, I say here, wait for event, wait on event here. Okay, my event. And then I say, for example, pause. So if I start that, it is counting these 5 seconds. This task is waiting. And as soon as these 5 seconds are gone, the task is released. It is important that you set the second task here also to repeat, otherwise it is waiting only once for the event. So if I start again, 5 seconds, second task, and it's waiting again here. So that's the way you can synchronize several tasks. Of course, often you can do the same thing by making a loop in one task and then do something else and then jumping back, but sometimes it is easier to have separated in several tasks, and you can synchronize this with events here. If you need to automate your hardware setting, you can also use the measurement flow control. For example, I can say here, okay, this is my hardware setting for my test 1. And I store that hardware settings here in test 1. And I say in test 2, for example, I have other input ranges, scale it to something like that. And perhaps I need a channel more. And I store these hardware settings to a second file, hardware settings, test 2. And now I can say here, load settings, test 1. Then I start recording, wait on enough recording, I repeat that, I say I need 5 times this measurement. And then I load another settings, load settings, test 2, and then make another repeat, 5, start recording, so execute. It does change hardware settings. It's doing the measurement. And it has changed the settings here, so we can repeat that. Execute. First settings, 3 channel, 10 volt input range. Then next settings, again, 10 measurement. Thank you for your attention. I hope you've learned something about the functionality of the MFC and that this will simplify your workflow in the future.